So hello everyone, this is lecture 32 for the solid state physics, in which we were studying about the crystals, and we did one lecture on the crystal. Now this is second, and yes, it is second. Okay, so today we will study about the lattices. Means there is there is infinite types of lattice is possible in the space. In principle, it is possible to construct infinite number of space lattices by varying a, b, and theta in the two dimension. What are a, b, and theta? This is a and b, and this theta. So we can vary in any theta can be taken, a and b, and a, b, c, and alpha, beta, gamma in 3D. So if you have one more axis here, then a, b, and c, an angle between them, a, b, between the angle between a, b will be alpha, b, c will be beta, and a, c will be gamma. So you can vary these three angles or these three sides, and there are infinite number of lattices possible. Okay, for 2D also, for 3D also. But the Bravais lattices, he was a scientist, so there are infinite number of experiments, means not just infinite, there is several number of experiments are took place on the crystals, and we find out that there is limited number of structures are possible, the lattices structures, okay, in 2D and 3D also. So well, there is a probability that in the future there is a little more type of structure can be find, but most of the structures are already explored, and these are the given structures we will study today, and we call them Bravais lattices. Okay, in 2D we will have 5 lattices, and in 3D we have 14 Bravais lattices. Okay, so just forget them, we will study in detail this. Okay, first see this definition. So there are infinite number possible, but in solid only few lattices are permissible. Only few lattices are permissible. There are 5 in 2D and 14 in 3D, which are permissible, so the crystal can have the structure. Okay, so these allowed lattices are called Bravais lattices. The restrictions due to symmetry operators. So why there is restriction means only 5 and 14. So these restrictions are due to symmetry operators, and these symmetry operators can be any type, like transitional and rotational, reflection, symmetry operator, this SO, and inversion symmetry operator. A lattice is allowed only if it possesses at least one symmetry. Means there should be symmetry in the crystal structure, only that is possible, and one symmetry should be there. A lattice with zero symmetry element is not permissible. So there is no symmetry, then that lattice is not permissible. And if we talk about the means, let me make you clear about it. There is different kind of structures are possible, and different types of shapes are possible in the earth, in the universe. But you see there is means, let's take the example of a drop which drops from the means the water drop. So in rain we see that the droplets are in the circular shape, means in the spherical shape, because that possesses the smaller surface area. So everything in this universe trying to possess less to less energy, and that's how these structures are also, means these structures are in that manner, so that will be smallest energy possible for them. Okay, so that's why we get these only 14 lattices in the 3D and 5 in the 2D. Okay, and less symmetry will lead to less possibility of that structure. Okay, so and what type of symmetry we are talking about means, if you have a sphere, then this axis you have, if you rotate it, then this symmetry will be, it will be symmetrical, means if you rotate there will be no difference in the shape. But if you rotate this, then it will have the 90-degree symmetry, means after 90 degree it will come to the same position. And if you talk about a rectangular shape, then it will turn out to be 180 degree, only then it will come out to the original shape. So it has less symmetry, it has more symmetry, and it has more than this symmetry. That's how. So surface energy also differs accordingly, means we have this surface is less than this, and this is less than this, and that's how their energy. So hope you understand what I'm trying to convey here, that just like these systems, and we know that most of the things exist in the circular shape, but in the crystals these are in the these squares and cubic shapes. Okay, so these are the most symmetrical shapes in the crystals. So just take the analogy of this structures with that structures. Okay, so only 14 are possible. So I'm just trying to convince you that why it is only 14 and 5 in 2D and not more than that. Okay, now we will see these. The important thing according to exam is you should remember these all 5 and 14 lattices, how they are, and everything you need to remember I written here. In 2D you have these 5 kinds: square lattice, rectangular, hexagonal, rhombic, and oblique lattice. For a square, a and b will be equal and theta will be 90 degree between them, and lattice shape will be like this. In 2D it will be like a and b will be equal. This is a and b and this is 90 degree. In rectangular, a and b will be different in length, but this is 90 degree. In hexagonal, a will be equal to b, but this angle will be 120 degree. In rhombic, a and b will be equal, but angle can be anything. So this will be like this. Oblique lattice, a won't be equal to b and theta can be anything. Okay, so this is oblique lattice. Only these are 5 possible lattices in the 2D. In the 3D we have these 7 kind of structures, and they have different types of structures in itself. First let me give you this example. Simple means the simple primitive structure it have will be represented here. Then body center means there is one particular atom in the center. Base center will be like this. At the upper base and at the upper and the lower base there will be atom, and the corners. In face centers there will be atom at every face and corners. Okay, so for cubic, ABC will be equal and all angles will be 90 degree, and only 3 are possible. This is simple cubic, body centered, and face centered. So simple will be possible, body centered will be possible, and face centered. This won't be there. For tetragonal, A will be equal and B won't be equal to C. Angles will be 90 degree, and simple and body centered are possible here only. So only these simple and body centers are possible. So for tetragonal, you know this kind of structure, just join it with this, so it will be tetragonal type. Now in orthorhombic, A won't be equal to B, B won't be equal to C, but all angles will be 90 degree, and all kind of structures are possible here: simple orthorhombic, base centered, face centered, base centered, and body centered, all. So all will be possible, and this will look like base centered. This is base centered, okay, and this is face centered. So all will be possible in the orthorhombic. In the hexagonal, A will be equal to B, B will be equal to C, B won't be equal to C, and alpha will be 120, beta gamma will be 90 degree, and only primitive hexagonal structure will be possible. So this will be just primitive structure, means 1 2, then here you place the atoms like this, and when you join them it will look like this. And this length is A, this length is B, and this length is C. So A will be equal to B, but this won't be equal to C, and the angle between A and B is 120 degree, and the AC and BC angle will be 90 degree. So this will be your structure only. In the trigonal, we also call it rhombohedral. So all angles will be equal, so all sides will be equal, and all angles will be equal, but angle won't be 90 degree. Only primitive simple structure is possible for trigonal. This will look like this, so it will kind of rhombus. Okay. For monoclinic, no sides are equal to each other. A won't be equal to B, won't be equal to C. Alpha beta will be 90 degree, and gamma won't be equal to 90 degree, and simple structure and body centered are possible here. So this will be simple and body centered. For triclinic, this will be same like this. A won't be equal to B, B won't be equal to C, and no angle is equal to each other, and they won't be equal to 90 degree also. And only simple structure is possible for triclinic. It will look like this, means A won't be equal to B, B won't be equal to C, and alpha, beta, gamma are not equal to each other, and they won't be equal to 90 degree. So only this structure is possible. Now total structure will be 1 2 3 4 5 6 7 8 9 10 11 12 13 and 14. So these are the 14 Bravais lattices which are possible in the 3D, and these are the 5 lattices which are possible in 2D. So just revise them and remember them, and must remember them. Okay, thank you everyone. Just end this lecture here.